Welcome to another episode of the 12 Days of Christmas series. Today I will be programming a Christmas themed card magic game. Here you can see I have the Pygame template ready for myself. I have my window initialized, my font imported, and my main function loop. This line here is filling the screen with the color purple. So if I run the program, you can see exactly all that. So I'm going to start off with making a new file called card where I'm going to have my card class in it. So I'm going to name this card, import Pygame, and I'm going to write my card class. And I'm going to inherit from Pygame's sprite class. And then in my init method, the parameters I need are a group, so Pygame sprite.group, an image, a card type to check for equality, and a position, which is going to be a tuple. And I'm going to call the init method of my superclass, which is sprite, and pass my group into it. So here I have a cover image of the back of the card, and here I have the different types of cards, the 4 different images. So we're going to have to flip through them. So I'm going to make a cover, which is going to be image load, and it's going to be the basic card cover one. And then I'm going to make a front image on the card. So image and copy, and my self.type is going to be my card type, and my current card is going to be the cover. And just a couple more things, I need a rect. So I'm going to get it from my base image since there's the same resolution anyway. And I'm going to make the top left equal my position. And then the parameter that we're going to need to check if it's facing up or down is flipped. So self.flipped, and we're going to set it to false for now. So if we make a draw method to show it on the screen, we can say screen.blit my current card at my rect. And in the main file, I'm going to import card from my card file. And right above my main function, I'm going to make an instance of it. So card equals card, and we're going to pass in values for its necessary parameters. So let's make a group called card group. So Pygame sprite group, and we're going to pass this through there. Then it needs an image. So I'm just going to quickly import one of the images. So card image, and I'm going to say Pygame image load from res cards and 0.convert alpha, and pass in through there card image. And let's say its card type is 0 for now. And the position I want it at is going to be window width divided by 2 and window height divided by 2. So now if we use the draw method on this card and run the program, you can see we have a card here. So now that we have a card showing on the screen, let's make a method to flip it over. I'm going to call this method user input and pass in my user events. For ev in events, if event.type is mouse button down and event.button is the left click, so 1. If self.rect.collide point with event position, which is the same as my mouse position, then I want my flip to be the opposite of what it was before. So if it's false, I'm going to set it to not false, so true, and then the other way around as well. And there's one more thing we have to do to actually change the current card. So in our draw method, I want to say self.currentCard equals my image, so the front of it, if it's flipped, else I want it to be the cover. So right now it's false, so it's going to be the cover, and whenever I set it to true after clicking on it, then it's going to turn to the front of it. So if I go to my main file and type card.userInput and pass in my events, run my program, you can see when I click on it, it changes sides. So now to make a grid of them, and I'm going to import NumPy for this, import NumPy as NP, and then I want to make a random 4x2 grid of these cards. So the way you do that is by starting with card array and calling NumPy's tile function. And the tile function basically repeats a range of numbers as much as you'd like and turns it into an array. So I'm going to use NumPy a range between 0 and 3. So I'm going to max it out at 4 because it's exclusive. And I'm going to loop it twice. And that's going to give me random numbers. And that's going to give me basically 0, 1, 2, 3, 0, 1, 2, 3 in an array. And you can see that if we were to print it. So when I print card array, you can see 0, 1, 2, 3, 0, 1, 2, 3. But now I want to shuffle them. So I'm going to say NumPy random.shuffle, and I'm going to shuffle my card array. And this is an in-place operation, so we don't have to reassign the variable. If I run this now, you can see it's a random arrangement of the numbers that we saw earlier. And now to shape it into a 4x2 grid that we can get a position from and spawn our cards in those positions. So here's where I'm going to reassign the variable. Card array equals card array dot reshape. And this is going to turn that one-dimensional 4-number array into a 4x2. So I'm going to say reshape 4, 2. And if I print it again, you can see we have a 4x2 array. So now to put this to use when spawning cards. So we're going to make a for loop using NumPy's ND enumerate function. So for position and value in numpy nd enumerate, pass my card array in there. Then I want to spawn a card instance. So I'm going to grab this, put it in this for loop. We can delete it there, move the group line right above it. And now that it's being put in a group, we have to iterate through it. So in the main loop, for card in card group, I can move these forward and it'll work as intended. And now we have to change the arguments that we give the card class, because now they're going to be custom. So for the card type, I'm going to just put the value in, and instead of giving a manual position, I'm going to give it the position in the array. So if I run this now, you can see they're all bundled up here, and that's because it's a range between 0 and 3. So we have to amplify it. And I basically multiplied it by 140. I found that to be the best. So I'm going to make a variable called scale and make it 140. And now we can make a scaled position with the x being multiplied by the scale and the y being multiplied by the scale. So now instead of position being the argument, we make it scaled position. So if we run this now, you can see we have a 4x2 grid of cards, all with the same image. And this is an issue that we're going to fix right now. So instead of loading one image, we're going to load a list and then index through that list using the value in the nd enumerate. And the way to write that, let's rename this card list, and then we can encapsulate this in list brackets. And instead of a hard-coded 0, we're going to turn this into an f string and then turn the 0 into an I. So this is what's going to run, and I is going to be for I in range 4, because I only have 4 images. And you can see my cards are numbered 0, 1, 2, 3, and with this default range, that'll work. So now in my argument, I want to name it card list and index using my value. So now when I run the program, you can see when I flip all the cards, they are randomized images. And another thing that we can fix is the offset, because we don't want it at the corner. We want it near the center of the screen. And I found the best values for that was an X offset of 50 and a Y offset of the window height divided by 6. So now that we have the offsets, I just want to add them to our calculation, the line right after. So now running the program again, you can see that the cards are centered on the screen. So now how do we check if the cards are the same or different when we flip 2 of them? We want to make a flipped cards group, first of all. So now that we have our flipped cards group, we want to add the flipped cards into that whenever we can. So after user input, we're going to check if the card has been flipped. So if card.flipped, then I'm going to add my card to the flipped cards group. Else, I want to remove it from the flipped cards group, or else it'll stay in there even when we flip it back. And this can be shortened to a ternary operator. So flipped cards.add card, if card.flipped, else remove. So now that we got that, we want to iterate through that group and check if they're equal or different. So in a new line, we can write an if statement. If the length of our flipped cards group is equal to 2, then I want to get a list of the sprites that are in that group. So I'm going to say lst equals flipped cards.sprites. And that'll return me a list of everything that's in it. And if the first card dot type is equal to the second card dot type, and type is nothing special, it's just the attribute that we had here. So if they're the same, then we want to iterate through it and kill them, because now we don't want them in the game anymore. So for matched in my flipped cards, matched.kill. And this will remove them from both the flipped cards and the card group. And at the very end, we want to empty the group. So flipcards.empty. If we run this now, you can see when we get 2 of the same, so those 2 are trees, that they clear. But how do we check if 2 cards are not the same? And this is going to take some event creation. So at the very top above the main function, I want to create an event called flip event. And we're going to use Pygame event custom type. And then we want to make a Boolean variable called flippable and set that to true at first. And then in our event handler, I want to say elif, my type is a flip event. Then I want to iterate through my card group and set them all to false. Then I want to iterate through my card group and flip them all over backside up. For card in my card group, card.flipped equals false. And this will turn them back up. So now that we wrote that event, we want to go down here and write an else statement. So else, in the case that they are not the same type, I want to check if it's flippable at the moment, which is set to true by default. And if that's the case, then I want to set a timer for this event to queue up. So Pygame time set timer. I want to queue my flip event at half a second and loop once. So basically, if the 2 cards are wrong, after half a second, it's going to flip back over and the timer is done. Now, the issue with this is that if we have 2 cards flipped over, it's going to keep setting this timer unless flippable is set to false. So this will not queue up again. So here I'm going to set flippable to false. And once this event has queued up, then I want to set flippable back to true. So now if I run the program, you can see if I get 2 wrong, it flips back over automatically after half a second. Those 2 are trees. Those 2 are cookies. That's a snowman. So it's 2 snowmans and 2 polar bears. Now that we finished the game, we want something to show up and congratulate us. Above the main function, I want to write a surface of text. So text surf font.render, and it's going to say you matched all the cards. And I do want anti-aliasing, and I'm going to make the text color white because the background is purple. And now I want to get a rect out of it. So text rect equals text surf get rect. And I want the center of it to be window width divided by 2 and window height divided by 2. So right at the center. And now to show it on the screen, we want to check whenever all cards are gone. So let's write another if statement. If the length of my card group is 0, so empty, then screen.blit my text surface at my text rect. So now if I run on program one last time, snowman, polar bear, 2 polar bears, gingerbreads, snowmans, trees. When we match all the cards, we get this prompt and we won the game. So that is it for today's game. I hope you liked it, and I will see you tomorrow in episode 10.